In the previous video, we have discussed about the effect of pole location and zero location on the system response. So we had considered only the pole and zero which were located at the left hand side of the S plane. In this video, we will understand the effect of pole location. Now here we consider when pole and zero location. So it is both. We'll see both pole and zero location. Now here we will consider when they are located at right hand side of the S plane. For that we will take exam 1 case 1, for which we have T of S is equal to S plus 2 divided by S minus 5. So here we can see that when we draw the S plane, so I'll draw the S plane. Your 0 is located at this position. 0 is located at this position where S is equal to minus 2, and pole is located at this position where S is equal to 5. So this is real part of S and this is imaginary part of S. Okay, so now for unit step input, the response C of t, what we get, okay, by following the normal procedure, the C of t we get is minus 2 by 5 plus 7 by 5 e to the power 5t. Okay, I have just avoided all the intermediate steps where we take C of s is equal to T of s into R of s, where R of s is equal to 1 by s. Okay, so C of s is equal to T of s into R of s. Then you take the partial fraction and then inverse of that. So that particular step has been avoided to save time. Okay, so C of t is equal to minus 2 by 5 plus 7 by 5 e to the power 5t. So here you can see that the power of e is positive. Whenever your power of e is positive, it means that the function is rising. If your power of e is negative, the function is decaying. This is the point that we need to keep in mind. Okay, so we can see that when the pole is located at the right hand side of the S plane, your power of e is positive, which means that the function is rising here. Okay, so when you draw the when you plot the characteristics of this function, so this is t and this is c of t. So when we draw this, this is how the characteristics looks like. 1. Okay, and the input for this one is u of t, which is similar to this. So here we can see that from the graph, we can observe that the input is bounded. The input is bounded. You can see, because as t tends to infinity, the value of r of infinity will remain 1. We know it is not infinity. Okay, so r of infinity is not equal to infinity. Clear? So this is a bounded input, whereas the output is unbounded. The output is unbounded. The response C of t, it is increasing. This is C of t. This is increasing as t tends to infinity. C of infinity is also equal to infinity. So your output is unbounded. So whenever, based on Bibo stability, We have discussed Bibo stability in the introduction class of control systems. So based on Bibo stability criteria, Bibo stability criteria, the system is unstable. The system is unstable. That is, for every bounded input, the output has to be bounded. Only then we say that the system is stable. But here we can see that the input is bounded, but the output is unbounded. Okay, and here we say that this system is unstable. So this is the reason why whenever you have a pole which is located at the right hand side of the S plane, the system becomes unstable. Okay, and we can observe it from the e to the power term. So if your e to the power is negative, the system, whatever function you have, it decays. Okay, and if you have e to the power positive, then it is rising, and as t tends to infinity, it will attain infinite value, which is against the Bibo stability criteria, and system eventually becomes unstable. So this is the effect of pole when it is located at the right hand side of the S plane. Similarly, we will see what effect it will have when the system is placed at the when the system 0 is placed at the right hand side of the S plane. Okay, so for that I'll take case number 2. So here I'll take T of S is equal to S minus 2 divided by S plus 5. So if your unit step input is considered, then C of t is equal to minus 2 by 5 plus 7 by 5 e to the power minus 5t. Okay, so when you plot this curve, when this is plotted, the curve looks something like this. This minus 2 by 5 value. And your r of t value is, this is r of t and this is c of t. So here you can see that the output is bounded only. The response output is bounded because we know what is the value of c of t at t tends to infinity, because as t tends to infinity, the c of infinity value is equal to minus 2 by 5. So you have a bounded output and the input is also bounded. So the system is stable here. The system is stable, but you can see that your steady state error increases. Okay, the steady state error increases. It is more than 100% now, because we had seen that in the previous video, that is in this case, as the as the zero location is placed away from j omega axis towards the left, the steady state error decreases. If you move more towards right, if you place a 0 more towards right, the steady state error keeps on increasing. So this is the effect of 0, which is located at the right hand side of the S plane. So the 0 will have no effect on the stability of the system. Stability of the system is entirely dependent on where your pole is located. But the 0 will eventually affect the steady state error. It will not affect the stability, but it will always affect the steady state error. Coming to pole, if you place a pole towards right hand side of the S plane, if it is more towards the right hand side of the S plane, then the possibility of stability, the possibility of instability arises. Thank you.